All right. We're going to go over the exam 3 review today. Here are my caveats. My caveats are that your problems may not be identical to the ones that I'm doing on the review. In other words, there are several problems on here that are multiple choice or true and false. Just because my problem is false does not mean yours is false. So you need to read the problem and determine what they're asking and determine whether it's true or false. Another example is they ask a question about how to decrease the probability of a type 2 error. Maybe that's not your question. Maybe your question, how to decrease the probability of a type 1 error. So just be aware that what I'm doing may be different from what you're doing, may be different from the review that you do, may be different than your test. So what's important for you to understand is what reduces a type 1 error? What reduces a type 1 error? There's only one thing you can do. Decrease the alpha. There's one way to decrease a type 2 error. What do you do to decrease a type 2 error? Increase the sample size. There you go. All right. So maybe those are things you write down on your formula sheet you bring into class. Let's get started. It's 20 questions long, and it doesn't take you that long to take the test. It just takes me that long to talk through the test. So it's going to take me the full 75 minutes. 51% of students entering four-year colleges receive a degree within 6 years. Is this percent larger? Maybe we'll highlight that. Larger than for students who play intramural sports. 121 of the 202 students who played intramural sports received a degree within 6 years. What can be concluded at the level of significance alpha is 0.05. So the first part of this question, they give you a drop down and you get to pick the test that you're going to use to solve this problem. Any idea what test you would use to solve this problem? What kind of distribution is this? Binomial. So what kind of test do you use for a binomial? A z-test. So this is going to be, from your drop down, a z-test, and I'm not going to write it all out, for a population proportion, correct? Very good. Okay, so what's our null and our alternative hypothesis? First of all, in the two drop downs in B, both of those need to be P here, correct? Because you're testing a population proportion. All right, so what are we going to pick in the second drop down? For the null hypothesis, it's going to be equals. I don't think they have any other choices if I can recall when I went through this. I don't remember there being any other choices. What's your choice for your alternative? Not equal, but what did I highlight? Larger, so what is it? Greater than. Okay, now again, even though the alternative can be greater than or less than, the null can just be equals. And as I said, I'm not sure, I did this last Thursday, I did this, or last Wednesday, whenever I did this. I'm pretty sure in none of the drop downs for the null do they have a less than or equal to or a greater than or equal to. I think they're all equal. So just be aware of that. Okay, so what do we put in the blank spaces? The null hypothesis is P is equal to 0.51. And you do want to write it as a decimal, not as a percentage. And it does tell me enter a decimal. So this would be 0.51 also, correct? Okay, so now I'm ready to go run the test. I'm going to run a z-test for a population proportion. And this is the only part of this that gets awkward. I have to switch. If I can. And let me share my screen. Okay, so I'm going to go over to my tests. So stat, test, A one proportion z-test is what, number 5? Okay, and my p sub 0 was that was the status quo. That's what you filled in for your null and your alternative hypothesis. So was that 0.51? If my mouse will work, 0.51. And they gave me some data, did they not? They told me that 121 out of the 202. So X is 121, N is 202. And then match what you have for your alternative. You had what, greater than? And make sure that you do match what you have for your alternative. That'll help me grade it. Even if you get your alternative incorrect, if your p-value and your statistic are correct, I'll give you partial credit for that. Okay, so let's calculate that. So our test statistic is 2.5306, and our p-value is 0.0057. And they do give me p-hat. P-hat is the 121 divided by 202. That is the proportion for the sample they gave me. Okay, so let's go type that stuff into my OpenMath. Sorry, I'm having to make sure that I'm getting this recorded properly. All right, so we had what, 2.5306. They tell me to do it to 3 decimal places. I put 4. It didn't count it wrong when I did that. And then my p-value was what, 0.00569, so 0.0057. That's probably better to put in. And I do check all these. There is one problem. It counted my p-value incorrect, and my p-value was correct. So I do check all these. All right, so it's your p-value. The next drop down is going to be less than, greater than kind of thing. So is my p-value less than alpha or greater than?
Less than.
It's less than. So since it's less than, what do I do? So in the next drop down, we reject the null hypothesis, correct? Okay, so now let's make a conclusion. So my final conclusion is what? Okay, I'm going to give you some hints because I'm nice. Since we rejected the null hypothesis, this is significant. The information is, your sample data is significant. So it is not the first one or the second. It's the last one, correct? And that's just a hint between the few of us that are in there. All right, and then it says interpret the p-value. And the p-value is the 0.005, correct? So it's the 0.5%, 0.57%. And the p-hat was approximately 60%. And we got that from when we ran the test. So we've got 4 choices here. It's not going to be the 2 short ones. And it's not going to be the last one. And how do I know it's the first one? I know it's the first one. I'm giving you all the hints. I shouldn't give you all the hints, but it's got population. And that's what you're testing. You're testing if the population proportion is greater than 0.51. So since that's what you're testing, that is going to be your choice. And they do give you some information about the p-value is 0.57%, so that's in there, and the p-hat 60%, that's in there. That's where that comes from. What did I just say? The wrong one, didn't I? No, I'm right. All right, the last one. This one, you're interpreting alpha. And alpha is the 5%. Okay, so which one is it going to be? If the population proportion of students who played intramural sports who received degree within 6 years is 51%, that's the status quo. And another 202 students who played intramural sports are surveyed, then there would be a 5% chance that we would end up falsely concluding that the proportion of all students who played intramural sports who received degree within is larger than. So what is a type 1 error? Alpha is the probability of a type 1 error. A type 1 error is what? Rejecting the null when it's actually true. So if you reject the null, you accept the alternative. If you accept the alternative, you accept the fact that it's over 51%. That is not true. So it's part A. It's part A because if you were to pick another sample, there's a 5% chance you could accept the fact that the alternative is true. Okay? And it's never the two little short ones, I don't think. All right, next one. Question 2. I get to say recidivism. Woohoo! Did you hear that? Recidivism. The recidivism rate for convicted sex offenders is 8%. A warden suspects that this percent is lower if the sex offender is also a drug addict. What's recidivism? Going back. Of the 313 convicted sex offenders who were also drug addicts, 19 of them became repeat offenders. What can be concluded at the alpha equals 0.01 level of significance? So what kind of test are you doing? What was that?
Would it be a Z test?
It would be a Z test? Is that what you said?
Yes, ma'am.
For what? Population proportion. And how do I know it's a population proportion? They give us percentages. So that's how I know it's a population proportion. Okay, so what do we have for a null and alternative hypothesis? So these are both P, correct? All right, so what are we looking for? Suspects that this percent is lower. So it's going to be, for the alternative, is that going to be lower? So the null is just going to be equals. And it's lower than what? What was the recidivism rate? 0.08. Okay, so we're going to run over and conduct the test. Oh, did I? Z. Forgot the drop down for the test statistic is Z. Same would be true for here, right? The drop down here is going to be Z. All right, let's go run this test. All right. So we're going to stat tests, one proportion Z test, number 5. Our P sub 0 was that recidivism rate of 0.08, correct? And what did we have of the drug addicts? 19 of 313. So 19 of 313 reoffended. And we're going to be doing less than, correct? We're going to match our alternative hypothesis. So our z-score, our test statistic is negative 1.2584. Our p-value is 0.1041 and p-hat is 0.06. Okay, so let's go back to my iPad. See, there's the only problem with computers these days is that there's always, I mean, one does one thing so much better than the other. And the iPad does notes so much better than the Surface Pro. But I can't get the emulator for the TI-84 calculator on the iPad. Very frustrating. All right, where was it? So the Z was what? Negative 1.2584. And the p-value is 0.1041. So what do we do? Is this p-value greater than or less than alpha? It's greater than. And I don't remember that drop down. I think they have less than or equal to and greater than. So they have less than or equal to, greater than or equal to, less than or greater than. I can't remember what it is. But just pick which one is appropriate from the greater than or less than. Does that make sense? Even though it has equals, go ahead and pick that. So what are we going to do if it's greater than? If the p-value is greater than alpha, what do we do? Fail to reject, which is right here. Fail to reject. We can't conclude that it's actually less than 0.08, correct? Okay, so what's our conclusion here? The data suggests the population proportion is significant. Well, it isn't. So it's either the second one or the third one. The data suggests the population proportion is not significantly lower than 8% at alpha 0.01. So there is statistically significant evidence to conclude that no, there is not statistically sufficient evidence to conclude because you're not accepting on the alternative, correct? You're failing to reject the null. So it has to be this one. Data suggests the population proportion is not significantly lower than 8% at alpha equals 0.01. You're not accepting the alternative. So it's not statistically significantly lower than 8%. Okay, the p-value is the probability of getting a value that extreme or lower. And p-hat was 6%, in case you were interested. Okay, so which one is this? It's not the first two, they're too short. Was the last one? How did you pick the last one?
Population proportion.
Population proportion. There you go. Interpret the significance, level of significance in the context of this problem. There's only one it can be. How'd you pick the first one?
Slower than the patient sex offenders and drug addicts would become repeat offenders slower than 8% instead of equal to 8%.
There you go. All right. Question 3. If n is 110 and p-hat is 0.2, construct a 90% confidence interval. In order to use technology, you need to compute the number of successes, X, because when you go over to your calculator and you go to your test and you look for a proportion interval, it's a 1 proportion Z interval is what you're looking for. You're going to have to put in X and N. That's all, and the confidence level. So those are the 3 things you have to put in. So I'm not given X, I'm given the percentage. I'm given p-hat. So X is n times p hat. Or p prime, they're the same thing. So it's 110 times what, 0.2? Which is 22. And so what I'm going to put into my calculator is 22 for x, 110 for n, and 90% confidence. Okay, so let me go back over here. Share my screen. Oh, there's so much work. Circus Pro needs to come with a good note app. Okay, so go to stat, test, and we need a 1 proportion z interval. That's a 1 proportion z interval. That's going to give me a confidence interval for a population proportion. We had what, 22 out of 110 with a confidence level of 0.9. Is that what it was? So the lower limit of our confidence interval is 0.13727. The upper limit's 0.26273. And we're just going to type that in. The lower limit in the first box, the upper limit in the second box. And it says 3 decimals, so I guess I should round this off. So it's 0.137 to 0.263. Okay, question 4. So you gotta have a few fairly easy ones in the mix. Okay, the next one, you're gonna have to put some data in your calculator. And this is the one problem I have issues with. So I do grade every problem, FYI. And this one I will take special note of when grading it, because I had issues both with the test statistic or the p-value, one or the other, I don't remember which one, and the conclusion. I had problems with both of them. Okay, so if you got that data, get that data in your calculator. And I'll read the problem while you're putting it in. I actually put a star by it because I have problems with this problem. Is the average time to complete an obstacle course different when a patch is placed over the right eye than when a patch is placed over the left eye? You know why pirates wore patches, right? Because it helped when they got in the dark, they could lift the patch up and it would help them see better, because that eye was used to the dark. Little known fact. 8 randomly selected volunteers first completed an obstacle course with a patch over one eye, and then completed an equally difficult obstacle course with a patch over the other eye. The completion times are shown below. Left means the patch was placed over the left eye, and right means the patch was placed over the right eye. Assume a normal distribution. What can be concluded at the alpha equals 0.1 level of significance? For this study, do you know what kind of test we're going to be using? What was that?
The T interval.
It's going to be a T test for what? Now, I'm sure if you looked at the drop down, you could probably figure this out. It is a T test. It's a T test for paired data, because you're looking at the difference between two related things, right? Someone's left eye and right eye. So this is a T test for paired data. So it's called a paired t-test to dependent means. Okay, so what's my null and my alternative hypothesis? All we're looking for is what? Different. And this is where I have a bone to pick with the author of the problem. So different to me means not equal to. And when I typed in not equal to, it gave me an okay. All right, so on this particular problem, you need to click in the box and it's going to open a menu, a little toolbox. And over one of the tabs is variables, and you need to pick mu sub d. So you're going to pick mu sub d. So it's from the toolbox variables. Anybody have that open? Is that what it looks like? It's a little tab over there. And you're going to pick mu sub d. And I got that it's not equal to, and it's not equal to 0. If you're doing a paired test, you're assuming that the status quo is there's no difference. And we have mu is equal to 0. Okay, so when you conduct this test, you're going to conduct this test on the differences. So you're going to put this data in your calculator, and then you're going to calculate the differences between the left and the right. So we're going to do a stat test. We're going to be doing a t-test, but we're going to be doing the t-test on the differences. Okay, so you got your data in your calculator. What am I doing? I don't know what I'm doing. I honestly do not know what I'm doing. So how do you find the differences in that data? Yes. So if I were you, I think I put the differences in just to save myself some work. I actually calculated the differences and put those in, which I did. So what I would do is I'd go over to L3, and you go up and highlight the L3. So you have to be up there. And then you're going to type in second one, L1, minus second L2, and then enter. And it should give you the differences, and it should look like L1, my L1. Have you got the same thing that I have in my L1? Yep. Okay. So that's what I'm going to run my t-test on, is on the 2, the 4, the -1, the 3, the 2, the 1, the 3, and a -1.
How do you ever subtract like the right from the left to the left from the right?
It doesn't matter if you're doing a difference. If you're doing less than or greater than, then you look at the alternative hypothesis. If it's mu sub d is less than 0, you would look at it. It depends on how the problem's worded, actually. So if it says, like the difference in the left eye, as a matter of fact, some of these problems, that's exactly what it says, that the time to complete when you cover the left eye is less than. So then you would do left minus right. Okay. All right. So I'm going to go run my t-test on my data is in L1. So on my data, we're assuming that the mean difference is 0, so that should be 0. I'm running on L1 because that's where I put my data. And what kind of test are we running? Not equal to? So my test statistic is t is equal to 2.488. By the way, if you run the correct test, it will tell you what test statistic is. So from the drop down, you're going to pick t equals. And what's my p-value? 0.0417. So my test statistic is t is equal to 2.4887, and p-value is 0.0417. Okay, so is my p-value bigger or less than my alpha? What was alpha? 0.1? So is that less than? So what do we do? Reject. The p is low, the null must go. All right, so this is where my bone is picked. So we're rejecting the null. If we're rejecting the no, we're accepting the alternative. So it looks like the data shows that there isn't a difference, correct? That's what the data is showing me. So alpha equals 0.1. There's a statistically significant evidence to conclude that the population mean time to complete the obstacle course with a patch over the eye is equal to when a patch is over the left eye. No, correct? No. At alpha equals 0.1, there is insufficient evidence to conclude that the population mean time to complete the obstacle course with a patch over the right eye is greater than when the patch is over the left eye. And the answer is, if I remember correctly, and I have it highlighted, this one. So I don't know why that's correct. That doesn't seem like that should be correct to me. It's insufficient evidence to show it's greater, but we did not equal to. So I don't think any of these are correct. So I'm going to grade this, obviously. I know that in the past, when you've done this problem, when I looked at this problem in the homework, it was a different, slightly different problem because it iterates, and it was correct because the problem looked at one eye being different than the, not being different, but being less than or greater than. So then the answer was correct. So I don't know. I will grade this one. I have issues. I studied this for like 20 minutes and I thought, I don't think any of those are correct. Okay. Move on though. Got to move on. This is problem 5. Does it take more time for seeds to germinate? At least I got a more than. More time. Does it take more time for seeds to germinate if they are near rock music than that is continuously playing compared to being near classical music? The 52 seeds that were exposed to rock music took an average of 20 days to germinate. The standard deviation was 15 days. The 53 seeds that were exposed to classical music took an average of 18 days to germinate. The standard deviation for these seeds was 5 days. What can be concluded at an alpha equal 0.01 level of significance? So what kind of test are you doing?
The two proportion t-test.
It is a t-test. For what?
Two proportion.
No, not proportions. And I know it's not a proportion because they give me an average. So it's a t-test for, it's either independent means or dependent means. And this is independent. So this is a t-test for 2 independent means. I mean, you're not germinating the same seed. You're germinating 2 different groups of seeds. So they're independent. One, you're listening to rock music, the other is listening to classical. Okay. So I'm going to let mu1 be rock and mu2 be classical, because in the drop downs, that's all I got is mu1 and mu2. So I have in the first, the null and the alternative hypothesis, it is more than. So it's greater than in the alternative. And it's what? That it takes longer for the rock music than for the classical, correct? So what's this? It's going to be mu1 equals mu2. Okay, so we're going to go run a t-test on two independent means. So we're going to run stat tests, two sample t-test. And we're going to run it on our stats because we're going to put our data in. We're going to put our stats in. We're not going to put data in. I can say this correctly. Okay. Okay, so I'm going to go stat tests. A two sample t-test is number 4. I'm going to do it with statistics because they gave me the averages and the standard deviation, correct? Okay, so for the rock music, it took an average of 20 days. So X bar sub 1 is 20 with a standard deviation of 15 days. And the sample size of my seeds that listened to rock music was 52. For the second group, the classical music group, took average of 18 days. So X bar is 18. The standard deviation of those seeds was 5 days. And the sample size was 53. And I do know that this is not paired data because I do have 2 different sample sizes. And with paired data, you have to have the same sample size so you can take the difference. Okay. And we're looking at, is one bigger than the other? Is mu1 bigger than mu2, correct? So greater than. Mu1 is rock music, mu2 is classical. Does it take longer for the rock music than the classical music? So we're going to go down and calculate. So our t-score is 0.913. Our p-value is 0.1824. So let's go put that in. So T was 0.913. The p-value was 0.1824. They told me to put that to 4 decimal places. So is my p-value bigger or less than alpha? Is it bigger? So if my p is high, then null must fly. So do I fail to reject? Okay, so what conclusions do we have? Did I not write them down? Okay. The results are statistically insignificant. It's this one, is it not? Is it the last one? You agree? It's because it's statistically insignificant and we're looking at a population mean. The other one that was statistically insignificant, this was the first one, Germany. Yep, that's it. Because more than. Okay, p-value. Population mean, it's got to be this one. Got to be the first one. Because it's the only one that has population mean in it. And then the last one, interpret the level of significance, which is the probability of getting a type 1 error. Population means in direct is the same as population mean for seeds exposed to classical test we did falsely concluding. No, it's this one. Because it was more than. Yeah,
Or
The-
is that right then? Cause that's population.
yes, we want population
Okay.
mean. We don't care about the sample. We're testing against what's happening in the population. All we care about is the sample is, does the sample show sufficient or insufficient evidence to support our hypotheses? Okay. Gonna have to put data in. A retailer wants to see if a red sale sign brings in the same amount of revenue than the same sale sign in blue. The data below shows the revenue in thousands of dollars that was achieved for various days when the retailer decided to put up a red sale sign, and days when the retailer put up a blue sale sign. So I put this in L2. You can put it wherever you want to. I put it in L2 and I put this in L3. So what kind of test are we conducting? So we're looking for the difference in these two things. So these are independent. Two different signs. And so it's going to be what? A t-test for the difference between two independent population means. Okay, so what's our null and our alternative hypothesis? I'm letting mu1 be red and mu2 be blue. So we're interested in what? Only interested if they're different. Is that what we're interested in? Same amount. So this would be what? Mu1 equals mu2, and this would be what? Mu1 does not equal mu2. And this is well, I will shut my mouth. Have you got that data in yet? And you do have to have it in two separate lists because you're checking two independent population means. So we're going to be using stat tests to sample t-test with our data. Okay, are you ready? Okay, so stat tests a two sample t-test on my data. I put my data in L2 and L3, the frequency both as 1, and I'm running what, not equal to? Okay, so my t-score is 0.7665. My p-value is 0.4545, and that's pretty much all I need. Okay, how many decimal places? 4 decimal places, 0.7665. So that is T. And the p-value is what? 0.4545. Okay, so the p-value is what? Is that greater than alpha? 0.45 is greater than 0.1. So based on this, we would what? Fail to reject? The p is high, the null must fly. Okay, so which one of these is it? Well, they're not statistically significant. The last one? I agree. Okay, what's the next one? It's got to be the last one. Population mean. The sample mean, that's not what we're testing. Okay, so what's this one? We're interpreting the significance of the level of significance. First one, how'd you get the first one?
Population mean, not sample mean.
There you go. All right, now it's going to ask you to calculate a confidence interval. So you're going to be calculating a confidence interval on a 2-sample test. So this middle is going to be mu1 minus mu2 because you're looking at the difference in the means. Are they different? Okay, so let's go back over here and let's decide which one we use. Which one do we use? A 2-sample t interval? Is that what we're using? On our data, correct? L1 and L2 is where I put mine. What was our confidence level? 90%. So my lower limit is negative 0.4089. My upper limit is 1.0489. So in parentheses at the top is my lower and my upper limit. Okay. Here we go. Okay. Problem 7. Are Republicans less likely than Democrats to display the American flag in front of their residence on the 4th of July? Probably not, but let's find out. So this is going to be a 2-proportion test, correct? Because they gave us some information. 406 of the 673 Republicans surveyed displayed the flag on the 4th of July. 454 of the 694 Democrats displayed the flag on the 4th of July. What can be concluded at alpha equals 0.01 level of significance? So this is a z test for the difference of 2 proportions, correct? It's binomial, but you got 2 proportions. So this is a z test for the difference. And I'm not going to write all this out. 2 population proportions. And so it's going to be, what are we looking at? That the proportions of Republicans, which we're gonna call P1, let's call P1 Republicans. And P2 Democrats. So P1 is less than P2. So it's going to be P1 is equal to P2. This is the problem. It counted my p-value incorrect. So let's see if you get the same p-value I got. And I do have those both highlighted in my notes to look, make sure to look at on your tests, although I do grade every problem. So we're going to be running a z-test. We're at two population proportions. A two proportion z-test number 5. Okay, and
Is it 2 proportion or 1?
oh, I made a mistake, didn't I? Thank you. Hit the wrong button. Yeah, I first saw that and I thought, well, that's not right because it's asking me for a P0. I ain't got one. So thank you for pointing it out. I did pick the wrong one. Okay, so what did we get for the Republicans? We got 406 out of 673. So 406 out of 673. And how about for the Democrats? 454 out of 694. And we're interested in, is the Republicans less than the Democrats? So is P1 less than P2? So I get a z-score of negative 1.948 and a p-value of, no, it was my z-score they told me was wrong. 0.0257. And I don't remember what they told me my z-score was, but it was incorrect. They tell me to round it off to 3 decimal places. So if I round that off to 3 decimal places, I get negative 1.948. Is that what you guys got? And their answer was negative 1.950. I don't think so to 3 decimal places. I think I'm right and they're wrong. And it counted it wrong. So don't get all bent out of shape if you see it counts that wrong, because I will be sure to check it. So we get a z statistic of negative 1.9481. At the 3 decimal places, that's 0.948. And my p-value was what? 0.0257. And what do we got? The p-value is what? P is, what was alpha? 0.01, so that's bigger. The p is high, the null must lie. So we're going to fail to reject. So what do we got? Which one is true here? Second one? Okay, how about the next one? Is it going to be this one? I think so. And the last one. What was that? First one? I agree. All right, then some quick ones. You ready? I know, it's already 20 minutes till. 95% confidence interval for the mean was computed with a sample size of 100 to be 10 to 14. So the error is plus or minus 2? True or false? Is that 12? That's the mean. So if you add the lower plus the upper and divide by 2, that's the mean. So is 10 to below the mean and 14 to above the mean? So is the error plus or minus 2? Okay, now yours may not be true. FYI, just be sure you check it. If the sample size is increased and the standard deviation and confidence level stay the same, then the margin of error will also be increased. As a matter of fact, what decreases the error is increasing the sample size. Okay, if n is 11, x is 36, and s is 20, construct a confidence interval at a 90% confidence level. So you need to go create a confidence interval. So what are you going to use? The t-interval? So stat test t-intervals number 8. And we're going to use our statistics, correct? And what did they give me? That the mean is 36. And the standard deviation was 20. With a sample size of 11. And we're calculating a 90% confidence interval. So the lower limit's 25.07. And the upper is what, 46.93? I'm gonna skip ahead and do a few things that are easy. Because I got 15 minutes left and I'm out of time. And then we'll go back and look at what we need to use. Okay, so there are some easy problems toward the end. 16, 17, 18, you actually have to do a calculation. Question 20, you just answer. Okay, so 16. Suppose the results indicate that the null hypothesis should not be rejected. Thus, it is possible that you get a type 2 error. Given the type of error made in this situation, what would you do? Increase the sample size. A 2011 Gallup survey based on telephone and face-to-face interviews with 4,220 adults in China, age 15 and older, suggests that 30% smoke regularly or occasionally. That's disturbing. The following is also noted. One can say with 95% confidence that the maximum margin of sampling error is 2.1%. Which of the following is true based on the results? If the sample size was larger, the margin of error would be larger. Nope. We are 95% confident that 25.8% to 34.2% of all Chinese adults smoke. Exactly 30%, no. We are 95% confident that 27.9 to 32.1% of Chinese adults smoke. If we were randomly sample another group of 4,220 Chinese adults, we would find exact, nope. So it's either the second one or the second to the last one. Which one is it? Why is it the second to the last? Because it's got the correct margin of error. Okay. Margin of error was 2.1. So that would be what? 27.9 to 32.1. Okay. In a 2011 survey by the Bureau of Labor Statistics reported that 91% of Americans have paid leave. In January 2012, a random survey of 1,000 workers showed that 89% had paid leave. The resulting p-value is 0.0271, thus the null hypothesis is rejected. It's concluded that there has been a decrease in the proportion of people who have paid leave from 2011 to 2012. So what kind of errors possible in this situation? Why is it a type 1?
That rejected when it's true.
The only way you can get a type 1 error is if you reject the null when it's true. If you're rejecting, that's the only type of error you can get. Okay, which of the following would result in the widest confidence interval? Well, it's got to be one of these. Widest, correct? Widest would be with a small sample size. So if you increase the sample, it narrows the confidence interval, narrows it up. So it's got to be the one with the smallest sample size. Which one makes it wider?
99%.
The confidence level. So the EBM is Z times sigma over the square root of N. That's how you calculate it. And the larger your confidence level is, the Z gets larger. So Z is larger here. So if you have a bigger Z and a smaller N, that EBM is going to get bigger, correct? And it's going to make a wider interval. Okay, so in our last 12 minutes, let's look at what tests you would use for the rest of these. That's not going to change from my problem to yours. Okay, so this is problem number 11. You're interested in finding a 95%. So this is just a confidence interval, isn't it? Using your data. Get back to the correct one. So you would use a t-distribution, and you would just use a t-interval for the data. So put this in a list, and then do a t-interval based on your data. Okay, and then at part C, if you get this wrong, I'm going to come look for you. So what's my confidence level? 95%. So is that 95 and that's 5? If you get that wrong, I'm looking for you. I got, and you're not going to have the same problem, but I got negative 0.10178 and 0.018. That's what I got. Okay. News group is interested in constructing a 95%, so another confidence interval for the difference in proportion of Texans and New Yorkers. So this is going to be a 2 proportion Z interval. And the reason it is a 2 proportion Z interval is this is binomial. And it's binomial because you're looking at 2 different groups and you're looking at a proportion out of that group. So you're going to be using a Z or a normal approximation to the binomial. So you would use a 2 proportion Z interval and then just plug it in. I think I told you something incorrect. This is incorrect. So I was looking at the wrong problem. This is 8 point, and the answers I wrote in there made no sense whatsoever. 8.8. 0.397. And this is 20.16. If I've got data, I better get something between. Yeah, anyway. This one I got negative. And again, if you get the second part of this right, I'm gonna come looking for you. Okay, problem 13, surprisingly, we should probably do this one because surprisingly enough, 13 and 14 you get incorrect. You're performing a two-tailed test with a test statistic z equals 2.19, find the p-value. So you're conducting a two-tailed test with a z equal to 2.19. So half the p-value is in each tail. So you're going to do an inverse normal? No. You're going to do a normal. So the p-value, where do I want to write this? Let's write it up here. The p-value is 2 times the area under the curve to the right of 2.19. So we have to multiply it by 2 times normal CDF. And we're starting at what, 2.19? And we're going as far right as we can. So we're going to put 1E99, 0, 1. And I do have to multiply that value by 2 because half the p-value is to the left of negative 2.19, and half of it's to the right. So you have to multiply it by 2. We run that test so much that we forget how to do a p-value by hand. So we're going to go to our distributions. Actually, let me clear this out of here. Let me put 2 times, and then we're going to go to our distributions, and we're going to do a normal CDF number 2. We're starting at 2.19, correct? And we're going to 1E99, which is already set on mine. If you don't remember how to get the E, the scientific notation, that is above the comma. That's the EE above the comma. So what do you get? 0.0285? The second question says, problem 14 says, you're performing a two-tailed test. If alpha is 0.05 and the test statistic is negative 2.34, do you reject or fail to reject? So if it's a two-tailed test and the test statistic is negative 2.34, then you're going to look for the area under the curve to the left of that, and you're going to multiply that by 2. So it's going to be a normal CDF again. So 2 times normal CDF number 2. But now you're going from negative 2.34 to the left. So this is going to be what? Negative 1 times 10 to the 99 to what? The negative 2.34. So the p-value is 0.019 or 0.02. So half the p-value is here, there. So the p-value is 2 times the normal CDF of -1 E99, -2.3401, which I got 0.02. So we're comparing that to 0.05. So the p-value is lower than 0.05. So what do? Reject. Now, will your problem be a reject? It may not be. It may be a fail to reject. But you do have to calculate the p-value. Will your test be two-tailed? Maybe not. It may be left-tailed or right-tailed. So be sure you read the problem on what you need to do as far as testing goes. Okay. I've got 4 minutes, so let's just go over what each of these will be. Poverty in Alaska. So they're giving you 29 out of 360. So it's some kind of proportion, correct? But you're comparing two proportions. You're comparing Alaska and Hawaii, correct? So this is a 2-proportion z-test. Because you're comparing 2 different proportions. And we're looking to see if they're different. Poverty, a difference. So this would be what? Not equal to 0. Oh, actually, we're doing P1 and P2, sorry. P1 and P2. This would be P1 equals P2. And they do ask you to find a confidence interval. To find the confidence interval, you use a 2-proportion Z interval. Because you got 2 proportions and you're calculating a confidence interval. So that's the one you would use. Problem 16. We did. Problem 17 we did. Problem 18. Nationally, patients who go to the emergency room wait on average, so some kind of mean, correct, of 5 hours to be admitted into the hospitals. Do patients at, oh, so now we're comparing rural, well, we're not comparing 2 hospitals, we're comparing rural hospitals to this waiting time, aren't we? Do patients at rural hospitals have a higher waiting time? The 13 randomly selected patients who went to the emergency room at rural hospitals waited an average of 6.1 hours to be admitted to the hospital. The standard deviation for this was 1.6 hours. What can be concluded at an alpha equals 0.1. So this is a t-test for a population mean. You're only comparing the rural hospital to the status quo. And what's the status quo? 5 hours. So we're using a t-test for a population mean. And that is a t-test. And we're interested in if the rural hospital is more than 5 hours. If on average they wait 6.1 hours with a standard deviation of 1.6 hours, is that statistically significant? Well, I got 2.479 for T with a 0.0145. That is less than, correct? So we're going to reject. It appears that they wait longer, doesn't it? Looks like. So which one is it? It's got to be this one, doesn't it? All right, any questions? All right, we'll see you on Wednesday.